All right, hello. Today we're going to be talking about angles and how you measure them, what it means when they're the same, and eventually we're going to use these to justify our problem solving. But let's just talk about angles. So what's an angle? So an angle is it's something that's formed. I would call it like kind of like an opening that's formed when two straight lines, line segments, rays, when they intersect. And the lines or line segments could represent anything. So this could be like a door that's open, or it could be a pair of scissors or something like that, right? So any two straight things that connect at some point make an angle. And the angle is the amount of openness that they have. So the angle is, a lot of times we draw it like this, but it's how open these are. That's the angle. So when you measure an angle, what you're measuring is how open is it? One of the things that you need to know when you're talking about angles is it actually doesn't matter the size of the lines. What matters is how open the lines are, or how far apart they are rotated away from each other. So I tried my best to draw three angles that are congruent. You can kind of see that all three of these angles are open by a similar amount, even though the lines that make this angle are bigger than they look bigger than the lines that make this angle. They look bigger than the line segments that make this angle. So angles are a measurement of how open or how much of a rotational offset that two straight items are. Okay. So what does it mean when they're congruent? Congruent is another word to say that they have equal measure. So two angles can be like, I really tried my best to make these congruent. If they all measured the same, then they would be considered congruent, right? If they were the same amount of open, if they were the same rotationally offset in comparison to each other, right? Okay, so that's what angles are, and that's what it means for them to be the same. There's a couple of special cases that I want to talk about. The first one is if you've got two straight lines or line segments or rays that intersect, you're going to get four angles, and we can number them here. 1, 2, 3, 4. Now, in the type of geometry that we do in high school and in a lot of geometries, the angles that are across from each other are congruent. So if I measure how separated those are, how open those are, it's going to be the same as these ones. And if I try to measure how open these are, that's going to be the same as these ones. So in this case, these angles, they are only sharing a vertex. The angles that are the same are only sharing a vertex. So this angle here, right, and this angle here, it's not sharing any of its sides, like it's not overlapping, except for the vertex of an angle. So we call these vertical angles because the vertex is the only thing that's overlapping. And remember that this is like one continuous line and this is another continuous line. So vertical angles are congruent. That's one of the facts that you're going to be using here to justify some other statements. So vertical angles are congruent. Okay, the last one involves corresponding angles. So for this, we need a pair of parallel lines. I'll try my best here to make some parallel lines. Okay, these are supposed to represent parallel lines. If you've got parallel lines and you've got a third line that's going to come in here and it's going to intersect, it's going to make four angles. 1, 2, 3, and 4. It's going to make four angles whenever it intersects with this one. And if we keep going in a straight line, we just keep going, following the line, just extending it out, it's going to make four more angles when it intersects the second parallel line. which we can number 5, 6, 7, 8. Now, because these two lines were parallel, when this third line intersects is extended to intersect this parallel line out of the two, the four angles that it makes are then duplicated whenever this line extends to intersect this one. So angle 1 and angle 5 are copied, right? So angle 5 is like a copy of angle 1. Angle 6 is a copy of angle 2. Angle 8 is a copy of angle 4, and so on. So this idea tells us that angle 1 is congruent to angle 5, right? Angle 2 is congruent to angle 6, and so on. This concept is called corresponding angles. So angle 1 and angle 5 are corresponding. Angle 2 and angle 6 are corresponding. So corresponding angles are congruent, given that the lines are parallel, right? So these lines have to be parallel, and then corresponding angles are congruent. All right, that wraps us up for this video. See you next time.